subtopic kinds of quadrilaterals from understanding quadrilaterals, which is the third chapter in NCERT textbook class 8. So here what do we mean by a quadrilateral? In the earlier video we have already seen that a polygon is a simple closed curve consisting of made up of line segments, right? Now a quadrilateral is a polygon of 4 sides. Okay, four lateral sides, right? So a quadrilateral is a polygon consisting of 4 sides. So here they have started with a trapezium, which is a particular type of quadrilateral which has a pair of parallel sides, right? Now this symbol here denotes parallel sides. Okay, now here you can see that these are the examples, these 4 are the examples of trapeziums, whereas these 3 are not trapeziums. Clearly in the first figure you can see that it is not a trapezium because it does not have any pair of parallel sides. Similarly, this quadrilateral is also not a trapezium because there is no pair of parallel sides here. Whereas if you see here, you can see that there is a pair of parallel sides. However, this is not a quadrilateral in the first place. That is, you can see that 1, 2, 3, 4, 5 sides are there in this figure, in particular polygon. That means it is not a quadrilateral. Therefore, it cannot be a trapezium, right? So these are the examples. Now here they have given us an interesting activity. So let us do this activity. What we are going to do is we will be taking identical cutouts of congruent triangles of sides 3 centimeters, 4 centimeters and 5 centimeters and arrange them as shown in this figure. Now here I would like to bring to your notice that this is nothing but a right angle triangle as it is mentioned in the figure here, right? How do we know that? Because you know that this is a Pythagorean triplet where 3 square plus 4 square gives you 5 square. Okay, therefore it is a right angle triangle, and since it is a right angle triangle, constructing and taking the cutouts is going to be quite easy for us. Okay, let us quickly look at these cutouts. So here you can see that I have taken 3 different colors and I am measuring 3 centimeters and 4 centimeters along the corner because these form the right angle, 3 and 4 centimeters, right? And then I am going to draw the hypotenuse simply by joining these 2 points because you can cross check that diagonal is going to be 5 centimeters. Okay, so here I have the cutouts. So what I have done here is, after realizing that these triangles are too tiny for the activity, what I have done is I have used a magnified version or similar triangles of larger size, right? So what I have done is I have taken, so without any loss of generality, I am simply going to magnify it 3 times. I am going to take 9, 12 and 15 centimeters instead of 3, 4, 5, right? That is again, it's still going to be right angle triangles, and it is going to be similar to the right angle triangles that they have given us, right? So here I have taken the same sheet again and I am measuring 9 centimeters and 12 centimeters this time on all the 3 colored papers, and I am going to take the cutout for the same. And I am going to mark the sides. Okay. Now here, instead of taking 9, 12 and 15, another thing that you could do is take 3 inches, 4 inches and 5 inches. It is again going to be a similar triangle to the given triangle. That is also fine. So here what I have done is I am going to mark the sides on both sides of the cutout. Okay. Right. So now my cutouts are ready to be used, and what I have done is I have placed a sticker on these 3 triangles, on these 3 cutouts, taking the orientation in the anti-clockwise direction, that is 9, 12, 15, right? Here also I have anti-clockwise 9, 12, 15, and here also I have 9, 12 and 15. Okay, in a short while you will understand why we have done this, right? So now arranging them in the manner that they have shown, in the activity, you will see that we get this particular quadrilateral, right? Now they're asking us, is it a trapezium or not, right? So let us check. Now we know that it is a quadrilateral. Clearly there are 4 sides to it, right? 1, 2, 3, 4. So clearly it is a trapezium. Now I need a pair of parallel sides. Now if you see, this side 15 centimeters is parallel to this 30 centimeters. It's quite clear from the figure, but in order to confirm that, you need to look at the angles. We cannot conclude it just by looking at it. Okay, so what angles are you going to consider? If you consider, for example, this angle over here, this is opposite to 9 centimeters here, right? And if you look at this angle over here, this is opposite to 9 centimeters. That means that these are alternate interior angles which are equal in measure. That means that these 2 sides are parallel if you consider this as your transversal. Similarly, there are other angles that you can consider to prove that these 2 sides are parallel to each other, hence it is a trapezium. Now in the activity they have asked us, using the same 3 cutouts, can you form any other trapeziums? In fact, they said that 2 other trapeziums are possible. Let us see how to form that. For example, I take out the green cutout from here and align it along this 15 centimeters. Okay. Now is this a trapezium? First of all, is it a quadrilateral? Yes, it is, because I have 1, 2, 3 and 4 sides. So it is a quadrilateral. Now if you look at these 2 sides, you will see that they are parallel. Again, you can confirm and conclude that these are parallel using the interior angles, or you can use either co-interior angles, or you can use alternate interior angles over here. Okay, and conclude that these are in fact parallel to each other, the 9 centimeters and the 18 centimeters. Therefore, this is a trapezium. Now, one more trapezium is possible. Let us check what that one is. So, if I were to align this along this is already the first one that we have done. Now, if I place green and go back to the original trapezium, and if I were to replace this over here, now you can see that this again is a trapezium, right? It has 4 sides, therefore it's a quadrilateral, and this time the parallel sides here are 12 centimeters and 24 centimeters, right? So this is also a trapezium. They have also asked us, if you look at this, they have also said, should the non-parallel sides be equal? For all the 3 cases, you can check immediately that the non-parallel sides need not be equal, right? So you can see here that the non-parallel sides are 9 and 15, and in this case the non-parallel sides are 12 and 9, and in this case the non-parallel sides are 15 and 12. So the non-parallel sides need not be equal. In case if they happen to be equal, if the non-parallel sides happen to be equal, we call it an isosceles trapezium. Okay. So with this, the first activity is done, and we are in fact done with this particular activity and the video. But here I would like to take few more minutes from you in order to explain something else, in order to look at something which is really interesting. If I were to flip one of these 3 triangles, what do you think is going to happen? Will you still get the same 3 trapeziums? Let us see. Okay. For example, I am going to flip the red colored cutout. Okay. Now this is clearly the same one, right? But if you play around with it, you will see that, for example, if I were to place it like this, now this is quite interesting, right? Now here I have a concave polygon, right? This is a concave polygon, and it has 1, 2, 3, 4, 5 sides, so it is a concave pentagon, right? In that manner, there are many other combinations that you can form using these 3 cutouts, which will give you different, not just quadrilateral but a pentagon, and it need not even be convex, it can be concave as well. So I have tried out and I got 10 possibilities, including the 3 trapeziums that we already got, right? So let me show you the 10 possibilities that I found out. So here, this is the first one, the second, third, the fourth one, the fifth one, sixth one, this is the seventh one, the eighth one, and this is the one mentioned in the textbook, right? This is the trapezium, the ninth one that we just formed, and the 10th one. So I found this very interesting. In fact, once you have the cutouts, anyway you're going to make the cutouts for the activity. I want you to play around with these 3 cutouts and see all the different possible polygons that you can form, right? So initially there were way too many polygons that I was able to form by flipping one triangle and then 2 triangles. Later when I listed all of them, I found out that there were too many repetitions and I could find 10 unique polygons that are possible. In fact, if you look at this in try to conclude this using permutations and combinations, then it will become a very interesting problem. But that is for some other video, for some other audience, right? So please do play around with the cutouts and try to look at all the possible polygons that you get. So that's the first activity in the trapezium section that they have given us. In the next video, I will be showing the second activity where you will be using set squares from your geometry box. Okay.